Welcome to IGBits. We train, you learn. A warm welcome to all watchers, listeners, remote joiners, along with direct joiners in today's session. We will review all our learnings in partial fractions. Rule number 1, 2, 3, 4. We'll recap what we learned and then see how you're going to apply for identifying given proper fraction to resolve into partial fractions. Without further delay, let's get started. Request to all viewers and listeners, if you have not subscribed the channel, please subscribe our YouTube channel. We have started uploading all learning videos on timely basis. Okay, a great help and great helping hand to extend who are actually in need would be a great, the support to the system, right? So we are trying to put our efforts to build the knowledge base, and then I want you all help us to share the knowledge sharing sessions to the your friend circles, extend your support and be a helping hand to build a great knowledge competency teams. Thank you all for your wonderful support so far, whatever you did it, but I would like and wish it to be continue further. Thank you all. Rule number 1 of partial fraction. Okay, what we talk about here, let f of x by g of x be the proper fraction such that in that case to each non-repeated factor, let's say g of x, if you can factorizing one of the non-repeated factors like ax plus b for the g of x, in that case there will be a partial fraction in the form a by ax plus b, where a is the non-zero real number to be determined. So a has to be determined, but a by ax plus b would be one of the partial fraction, a portion of the partial fraction for the proper fraction. That's what is given. So most of the times what we talk about, like for a given proper fraction, we have to decompose that into partial fractions. That's the problem statement, right? Let me give an example. Let's say we have 5x plus 1 divided by x plus 2 x minus 1. So the g of x can be x plus 2 and x minus 1. These two are in the form of ax plus b, right? And these are non-repeated factors, meaning appears at one instance. X plus 2 is one instance, x minus 1 is another instance. Both are like a products. These can be rewritten as in the form of partial fraction a by x plus 2 plus another non-zero real number b divided by x minus 1. If you can write this way and then determine a and b, right? Step 1, you have to split into partial fractions, and then step 2, you can find out a b constant. Step 3, replace them back. Then the answer is what you get is like a by x plus 2 by b by x minus 2. It means the sum of the partial fractions is what your answer for a given proper fraction. We will solve the few examples, then you should be able to understand. But the rule number 1 says that if f of x and g of x are the forms a proper fraction, then g of x can be a product of non-repeated factors. In that case, you can represent in the form a by ax plus b, b by cx plus d, where a and b are the non-zero real numbers. those to be determined for resolving or expressing a given function into partial fraction. So let's look at rule number 2 of a partial fraction. For a given proper fraction f of x by g of x, where g of x is in the form of ax plus b whole power n, we have a condition like a is not equal to 0 and then n would be a positive integer of g of x. In that case, there will be a partial fraction in the form of a1 by ax plus b, a2 by ax plus b square, so on, an nth term, an by ax plus b whole power n, where a1, a2, a3, a4 till an are the non-zero real numbers, are the constants non-zero real numbers. This is how we have to understand. The rule number 1 is non-repeatable, but rule number 2 is a repeatable case. A given proper fraction, if there would be a repeatable g of x in the power form, right? In that case, the way that you have gonna represent partial fractions are in this form: a1 by ax plus b, a2 by ax plus b whole square, and so on. Let me give you simple, the example. Let's say the case is, are you ready? Well, x square plus 13x plus 15 divided by x plus 3 whole power 3. How do you represent this one? You have to represent like a1 by x plus 3, that's the first term, plus second constant a2 divided by, you have to raise the power, x plus 3 whole square, then a3 term, a3 by x plus 3 whole cube. So we have a degree of 3 and then you should end with 3. That's what meaning of your n, right? N means n terms. Okay, this is ax plus b whole square till ax plus b whole power n. Got it? So this is how I think we have to represent the partial fractions. Okay, based on the rule number 2. Then rest of the solution is common as a rule number 1. Now let's look at what rule number 3 says. Partial fraction of f of x by g of x, where g of x contains irreducible factors. Okay, this is a condition. So we spoke about just now, right? When a given quadratic equation, if you are not able to find out factors, so what we are also termed as a irreducible factors, in that case, how do you gonna solve this problem, right? The rule number 3 is going to help you to identify this scenario and then give you a hint to resolve a given fraction into partial fractions. Let f of x by g of x be the proper fraction. Make a note, all the partial fractions we spoke about a proper fraction as a start point, right? You have to make sure the given equation is a proper fraction. From there you have to apply the rules. That is a, the hint, to solve the problems. Okay, to each non-repeated quadratic factor, so condition is you have a quadratic factor like a ax square plus bx plus c, where the factors cannot be made. So irreducible factors and a non-repeatable. In that scenario, for each term, you have to use something like ax plus b by ax square plus bx plus c, where a capital uppercase a and b are the real numbers which are to be determined. That's a clue. So now the question is how you are going to identify them. Okay, let me put a few examples and then see how easy we can find out. Let's say we have an equation called 2x squared plus 1 divided by x cube minus 1. If you look at this example, the degree of numerator, the degree of numerator, right, is less than degree of denominator. You all agree? Right? Because this is a 2, this is 3. So that means this is a proper fraction. So that is a first condition. We are good with that. Right? Next one, what you are saying is like find out for the this is a g of x, correct? For g of x, we have to find out a factors. X cube minus 1. This sounds to be a cube minus b cube. How do you solve this problem? Right? A minus b into a square minus ab plus b square. Is it correct? Or a plus b here. So now how do you solve this? How do you expand this? If you say x cube minus 1 can be written as x minus 1 into x square plus x plus 1. This is how you can write it. That's good. So this overall equation can be written as 2x square plus 1 divided by x cube minus 1 can be written as 2x square plus 1 divided by x minus 1 multiplied by x square plus x plus 1. See this, you can always think of when you have x cube, that means like the degree is 3, you should find out 3 roots for this, 3 terms. So if you look at here in the expansion, x minus 1 is the one factor and x square plus x plus 1 is the second factor. But this itself has a 2 values inside, isn't it? So you still need to find out factors for this. But question, will that be easy to do this? That is where rule number 3 concepts comes into place. This is non-reducible, irreducible factors for this given quadratic equation, because b square minus 4ac if you calculate, which gives like a negative value, right? So in this case you have to apply this method. For this particular term you have to use ax plus b by ax square plus bx plus c, the term, to resolve this. This one is probably the same. This you can apply a rule number 1, this you can apply rule number 3 in order to get the partial fractions for the given proper fraction. Okay, let's see the few sums. So rule number 4 is similar to rule number 3 except one additional condition. In rule number 3 what we studied is irreducible factors, but occurrence is only one. In rule number 4 what we are talking about repeated irreducible factors. Okay, if the degree of irreducible factor is greater than 1, then how you are going to solve these problems? That's what partial fraction rule number 4 tells us. Let f of x by g of x be the proper fraction, and then n is greater than 1, n is belongs to natural number, is the largest component, let's say ax square plus bx plus c whole power n is what given in g of x in the denominator. Then corresponding to each factor, right? Each irreducible factor for which a partial fraction exists in the form of ax plus b by same. So a1x plus b1 by ax square plus bx plus c plus a2x plus b2 divided by ax square plus bx plus c whole square and so on. You see this one, rule number 2, right? Repeated factors, rule number 2, and then irreducible factor, rule number 3, put together to arrive a rule number 4. That's simple. Okay, and then a1 b1 a2 b2 an bn, all these terms are constants, non-zero values or zero, depends upon your findings, but to be determined, and then plug in back into this expression to get a partial fraction for the given proper fraction. That's an idea. Okay, so let's give a small example which help you to identify rule number 4, how you're going to apply. Let me write down this one. Here I am supposed to be irregular. Okay, x given proper fraction is x plus 1 divided by, so irreducible factor that we studied also, right? X square plus x plus 1, and that this has to be repeatable, means like you put x square, is it? Then I can say straight away this is rule number 4, because this is x square power 2, like x to the power 4, right? Numerator degree is lesser than the denominator degree, and hence this is a proper fraction. Now this is irreducible factor, this is irreducible. Okay, then we have a square, so it's a repeated, irreducible repeated in g of x for a given proper fraction. Then obviously you have to use rule number 4. What it talks about, this one. How do you express this? Let's say ax plus b divided by x square plus x plus 1. This is first iteration. Go to the next one, maybe cx plus d divided by x square plus x plus 1 whole square, right? Because this is n is equal to, so I have two terms. This is how you can solve. Let's not confuse, because I use here like a1 x plus b1, a2 x plus b2. You can still use the same thing, a1 x plus b1, a2 x plus b2, then you can find out. So to make it our understanding easy, I just use like ax plus b and cx plus d. Otherwise you could also use something like this, a1x plus b1 and then a2x plus b2, so over x square plus x plus 1 here, and then x square plus x plus 1 whole square here. You still can use it, both are same. Alright, thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Logically, we reached the end of the session. We covered rule number 4 here. So far we covered rule number 1, 2, 3, 4, and then basic concepts are the prerequisites. Feel free to go back and revisit the previous sessions if you have any doubts, or post the query in the chat window so that we will respond you back. Alright, stay tuned to the next session. See you all again. Have a good day.